Hello, everyone. Thanks for having me here. Today, we will talk about OT cybersecurity, and I will share how to strengthen the industrial cybersecurity with internal segmentation, as we believe internal segmentation is a very effective way to defense your OT and secure your valuable operation. My name is Terence, and I'm CEO at TXOne Networks. TXOne Networks is a young startup. We were founded in 2019 by the cybersecurity giant Trend Micro. Although we are young, but we already have many reputable customers all over the world in different industries, including manufacturing, oil and gas, power utility, and transportation. And in manufacturing world, we have also different vertical customers like a pharmaceutical, automotive, semiconductor, motors, machines, and etc. And today, the sharing about the best practices and the internal segmentation are actually the learnings and experiences derived from the real cases. Before we get to the internal segmentation thing, let's talk a bit about the background. Why suddenly OT threats becoming so relevant to manufacturing world? Because before 2017, the victims of the specialized cyber attack were mainly the critical infrastructure, while the attackers are those nation-sponsored hackers. Back to them, manufacturers actually didn't pay so much attention to the cyber threats because they didn't have to, right? Number one, they believe their environment were mainly air-gapped. And number two, to be honest, there were not so many cyber threats or cyber incidents as well. But the cryptocurrency changed the whole world of cybersecurity, right? Now, cryptocurrency has become the most effective payment option for hackers. So from 2016, 17, and 18, we saw many run type of ransomwares like WannaCry and NotPaya, and they caused a lot of damage to the larger manufacturers. And from 2019, 20, 21 to now, and in the near future, the targeted ransomware, or it kind of impact the whole manufacturing world significantly. So we really have to pay a lot of attention to it. According to a cybersecurity survey conducted by Trend Micro last year, and they interviewed 500 respondents in 3 countries. They are US, Germany, and Japan. 61% of the manufacturers admitted they encountered at least once the cybersecurity incident. And 75% of the victims said the cyber incidents caused a production outage. And 43 of them said, the whole production line suspended for more than 4 days. So that's a lot of damage. And 59% of these respondents said one of the biggest challenges is the lack of ICS security solutions designed for the OT system and devices. So in addition to the behavioral change of the hackers, we believe the IT-OT convergence also accelerate the cyber threats in our world, because OT is now adopting the common IT technologies. Let's take a networking technology as an example, right? It's the same Ethernet, it's the same Wi-Fi, same 4G, and even 5G technology. And operating system, right, OT like IT, are using the same Linux and the same Windows. And even worse, in many manufacturers environments, there are a lot of obsoleted or end of support Microsoft Windows operating system, and they are vulnerable and very difficult to patch. So that make hackers feel home about it, right? They didn't have to develop new specialized technology to attack OT. They can use exactly the same technology. They break IT to break OT. This is another research conducted by Trend Micro in 2020. They discovered 127 new ransomware families. And the top 10 most detected ransomware families were mostly being detected in OT as well. So that proves our point. Hacker use the same technology to break OT, just like what they do in IT. And let's talk a bit about the different cyber attacks. So we have non-targeted cyber attack like a worm type, but I think we need to pay much more attention in this targeted cyber attack. And the first type is cyber criminal. Just like the goal, the whole point for cyber criminal to do this is for money, right? Just like APT a while ago, right? They break into the corporate with phishing email, or because of COVID-19, right? Now they leverage the vulnerabilities at the RDP gateway or VPN gateway, so they can exploit it, the vulnerability to break into the corporate. And after breaking into the corporate, they hide themselves and patiently lateral movement and wait until they got the high privilege credential. And so they can compromise the domain controller and deploy malware with the domain controller. And if we look into the famous ransomware all the way from Lakagoga to DarkSide, REvil, it's the same type. And the second type is the cyber espionage, which means the threat actors are those nation-sponsored hackers. So the way to break into the corporate are not so different, but the difference is in the last step. Because their main goal is not about money. Their main goal is to to bring the panic and to bring the fear, right? So they want to make a damage to maybe the human life or to the environment. So in the end, they kind of like manipulate the controller and the field device to make the damage. So if we review the cyber breaches like the Stuxnet, Black Energy, and Triton, they are all in this category. So if we take a closer look of the new MITRE attack metrics for ICS, MITRE released the attack metrics for IT a couple years ago, but comparing to the previous metrics in ICS version, we can see some difference. But let's explain a bit about these metrics. You see the red blocks. The red blocks are the tactics. Tactics are basically the procedures for hacker to break into the corporate and do the damage, from initial access, execution, privilege escalation, all the way to impact. And the blocks below the tactics are technique. The technique are the real, techniques the hacker used to achieve his tactical goal, such like the hacker use the try default credential, right? They try lateral tool transfer to achieve lateral movement. So with the understanding of this table, and we compare the ICS version with the previous version, and we found in the ICS version, there is no credential access tactic, right? Because as we explained, it's not about money, so it's not about distribute the malware and lock it down, and so at that time, it's more about manipulate the mission critical controllers and make the end device, the field devices, more functional. So instead of having the credential access for the domain controller, there are two new tactics. and they are inhibit response function and impair process control. And top on that, the final tactic, the impact of the ICS version is more severe. So we have loss of productivity and revenue, and the loss of protection, and more importantly, loss of safety. So let's take an example, the very famous ransomware REVO, or aka Sodinokibi infection chain as the example. So the hacker gained the access to the corporate by leveraging the RDP vulnerabilities. And then once they get with the RDP gateway from there, they try to do lateral movement to the domain controller. And you know, how did they identify and recognize domain controller? They can use the tool like NetScan. And once they have the high privilege credential and they can control the domain controller, right? They can connect back to the CNC server and download the malware and even steal the data, you know, the data exfiltration and send it back to CNC server. And the last step is to use the domain controller to shut down the antivirus software on the PCN server and deploy the malware. So this is a very typical way how a ransomware infect and impact the corporate. In addition to the hackers from outside, we also have to pay attention to insider threat, because in OT and the shop floor, we have much more complicated personnel comparing to the data center, right? We have our own employee, we have a technician from the tool machine, we have contractors, system integrators, and etc. So intentionally or unintentionally, they could bring in the malicious malware. Like last year in August, a Russian hacker group tried to propose $1 million to a Tesla employee and ask this Tesla employee to implant a malware in the Tesla factory. Luckily, this Tesla employee rejected and reported to FBI. So that's how we could learn about this. And at TXOne, we kind of like see the OT infrastructure as 3 layers, and they are OT servers, control systems, and the underlying devices, whether they are intelligent one like a robot arm or the passive devices like those mechanical pump and drillers. And if we look into the aforementioned 2 types of attack, cyber criminal and cyber espionage. For cyber criminal, they just try to encrypt everything, right? Just like encrypt your OT servers and maybe the control system and the underlying devices. But for cyber espionage, they you know, they want to go all the way down to the production line and manipulate the PLC, the controller, and try to make more damage to the field devices. But if we think more about it, if the application servers, the OT servers being encrypted, actually, we still have the operation outage, the production outage, right? Let's take the previously the cyber breaches at the Colonial Pipeline as an example. You know, when the dark side attacked Colonial Pipeline, according to the research, the pump, right, the mechanical thing are still all functional. However, the important application servers being encrypted. So Colonial Pipeline still had to shut down the whole operation. But if it's just the OT server and the application server being encrypted, you know, it takes less time to recover, right? You can cut down the network, make sure the hackers has no access anymore, and then you can restore the server and do the compatibility test and etc. But if you have thousands of control systems or field devices being compromised and infected, then the recovery time will be very, very, very long. And even worse, once the control systems or the field devices being controlled by the hackers, there will be damage to human and environmental safety, right? So let's think about Triton. The hacker tried to fill up the gas, right, until the tank was full, and they can light it up and cause the explosion, and that's pretty bad. So you really have to secure them all, from the OT server to the control system and the devices. So here we recommend the zero trust segmentation. It's about killing the kill chain. With the zero trust segmentation be deployed appropriately, we can not only disrupt data movement, detect and block tools like the net scans, like AVQ. We can also prevent those unusual behaviors, like group policy from domain controller and those strange control command, from being sent to the PLC. And not to mention, the worm propagation will also be contained. So there are 3 steps. Let's introduce them one by one. The first step is about network segmentation. In many manufacturing environment we have been looking at, many customers, they have big flat network because they want their network to be very efficient and very fast and very convenient. However, security is in the opposite side, right? Security is about inspection and control. But if it's a big flat network, once the worm type malware being brought into the environment, one single worm soon become 100,000 worms, because they are going to infect the machine one by one without being detected and blocked. And once the hacker get into the production line, the shop floor, without the network segmentation, right, they can easily browse and do the lateral movement very quickly. So you really want to have the segmentation being deployed between the production lines or in front of the mission critical assets. So think about a submarine, right? There are the watertight compartments within submarine, so that even there is one leakage in one of the compartment, the water would not flood to other compartments, so the submarine would still be fine, right? So without that, the submarine would sink very quickly. Think about that. And the second approach is about virtual patching, right? In our OT world, it's like impossible to keep our device and equipment up to date in terms of the patch management, right? We have to wait for the system downtime before we can do any patch. And after the patching, we have to do a lot of tests, right? The compatibility, the retro test. So it's so expensive. And in many environments, they simply give up. They don't patch. And so having the patching being deployed on the network would be the best way to address this issue. So this has been a practical and a very efficient way for like 20 years in IT, right? Once a zero-day vulnerability being discovered, before the software vendor release a final patch, you can install the network security solution like intrusion prevention system to shield that vulnerability effectively. That's very similar to before you have the vaccination, right? At least wear the mask to lower the risk. And once you have the network segmentation and the virtual patching, the third thing we would recommend you to do is the network whitelisting. It's a very granular access control, right? In our production line, we have so many controllers, and they could be Mitsubishi, could be Siemens, could be Rockwell, but very few of the manufacturers would implement the access control onto the controller. And so, but if we only do the access control based on IP and the VLAN level, it's far from enough, right? Think about the WannaCry propagation. WannaCry running on port 445, and that's an important port because in OT, we still do a lot of file transfer. So you are not able to block the SMB port. So you allow the peer talk to the other peer on port 445, but it's the same protocol WannaCry is running. So the access control based on device IP is use this. So we suggest not just the IP, but also on protocol, like between the peers, there are only certain protocols can be used to communicate with each other. And to take a step further, the control command, right? You can limit the access to a very mission critical asset. Say everyone can only read the configuration, but you are not able to configure, shut down, or do any actual damage. So network whitelisting could really prevent those unknown attacks. But in real world, it would be extremely difficult for people to manually set up the policy one by one, because there could be thousands of controllers there. So our technology is more practical. We have, thanks to the machine learning technology, we can do 3 steps: learn, inspect, and enforce. So we learn the whole network, who talks to what, on which protocol, and what control command, and etc. for like 2 weeks and 3 weeks. And then we propose a template. So with that template, you can deploy to the network security box and see if the template is sufficient. And you can fine tune the template a bit. And then once you feel comfortable, you enforce so that those communication, those unknown attacks will be blocked because it's not on the template we have been generated, right? And from time to time, if you have a new machine coming, you have a new operation, you can do some tuning on the template easily. So that's how we call it doable practices. But you don't really want to implement network segmentation, virtual patching, and whitelisting on 3 different solutions, right? Because that way, the management will be very, very complicated, not to mention the waste of the more space, more power supply, and etc. So you really want to implement all these 3 features in a single box or single solution, and comprises all these 3 features, including segmentation, virtual patching, and the whitelisting. We call it the zero trust segmentation in OT. And that's what we recommend you to implement. But securing OT is just difficult, right? We have vulnerable environment, just like I have mentioned, the legacy assets, the assets with legacy operating system, and patching is difficult. And we have big flat network and insider threats. But even if we want to implement the security countermeasure, the deployment could be also problematic. I think the first reason is separation of duties. Who is in charge of the OT security? It could be the IT guy, it could be the OT guy, it could be the networking guy, it could be the InfoSec guy, right? So in different company, the role is just different. But whoever take the lead in the OT cybersecurity will also sit down together with the other parties and make sure everybody being comfortable about the solution, right? So it takes a while, and you have to think about the availability is everything. You don't want the security solutions to interrupt your operation even without any attack. And the installation could be also complicated, right? You think about the limited space, the power, and the cabling, and right, and you need the security solution to provide you the central visibility. But with the separation of duties, it could be even challenging. So at TXOne, we think the solution has to be very adaptive to the environment. You think about different conditions, right? Who is going to manage the device? Is that the IT who prefer the device sit on the rack along with the network switches, or the OT guy who want to install a more flexible the device into the cabinet? And if it's into the cabinet, should the device support wide temperature? Do you have the air conditioning? And so does the device need to be ruggedized? And the device definitely need to provide fail safe, which means even you have a trouble with the hardware, you have outage of the power supply, the device, I mean, the network security box will not block anything, right? And the number of interfaces. If you install the network security box into the cabinet, maybe 2 segments is enough. But if you want the network security solution to protect the 48 segment network switches, maybe you need 96 interfaces. So there are a lot of options there, but they all have to be very adaptive to your environment. So let's take a real example in one of our customers. They are a very big automotive component companies, have like 130 factories all over the world. And they use 2 solutions. You know, they want to implement the zero trust segmentation. But one other issue they have is the duplicated IP. So like when they bought the robot arms, every robot arm comes in with the same IP address, and they don't change the IP address of the robot arms. So they need to our zero trust network segmentation solution also support the network address translation. So basically, they install the firewall in front of each production line, and maybe 100 to 200 firewalls per factories. But on some other factories, they don't have the duplicated IP issue. They install the big zero trust segmentation box onto just next to the 48 port switch, so that the IT guy can still, you know, stay in the air conditioning environment and secure the underlying production line remotely. So, you know, like I said, the solution need to be adaptive to the environment. The other example is the semiconductor fab. Semiconductor fab is a very complicated environment, but highly automated. And all the tool machine in a fab is very expensive. Nowadays, a gigafab normally it takes from $4 billion US to $10 billion US to build a factory. So the operation and the devices are really, really expensive. And this customer decide to protect every single tool machine with the zero trust segmentation. So they implement the deploy the network security solution next to their 24 port edge switch. So the tool machine, before connect to the edge switch, the traffic will be inspected by the zero trust network segmentation. And top on that, they also have some next generation antivirus and some white listing solutions to lock down those fixed function and the legacy endpoints. So summary, we believe OT cyber threats are so real because of the change of the cyber threat landscape. as well as the IT-OT convergence. And we recommend the zero trust segmentation. It comprises three things: network segmentation, virtual patching, and whitelisting. We believe by doing this, it will effectively defend your operation and your network and your asset. And we wish you a great success and secure operation on your journey to digital transformation in Industry 4.0. That concludes my sharing today. Thank you.